The boatmaster has to conduct regular inspections of the ballast tanks and associated pipework to identify any signs of damage, such as cracks, deteriorated welding seams, corrosion, or structural weaknesses. These inspections should include thorough visual examinations, non-destructive testing techniques, such as ultrasonic testing or magnetic particle inspection, and thickness measurements of the tank walls. Ideally, photographs should be taken and kept as a record of visual inspections. On entering the tank, the boatmaster observes the state of the access ways and the ladders, tank coatings, and makes close observations of areas susceptible to corrosion, such as near the weld joints. The boatmaster should examine the material wastage throughout the tanks. An overall study of the tank coating would permit a competent person to estimate how the tank has reacted to general corrosion. Maintenance and inspections of ballast tanks are needed to ensure the structural integrity of tanks. As part of a vessel's planned maintenance system, PMS, a robust maintenance schedule for the ballast tanks, including cleaning, inspection, and repairs should be implemented. Regular inspections help identify any potential issues or structural damage to the ballast tanks. This allows for timely repairs and therefore helps mitigate the risk of incidents. To ensure maintenance of the onboard ballast tank system, the following precautions should be taken. Accumulation of mud and sludge in the tanks could be detrimental in terms of hiding away serious defects, and also to promote the development of structural deterioration underneath the horizontal surfaces. Therefore, it is highly recommended to remove the excess debris prior to any tank inspection. This means physically hosing down the mud accretion in ballast tanks. This also aids in identifying any bottom shell pitting corrosion or deformations. The inspection includes checking manhole covers to ensure that sealing arrangements are free of debris, the gasket is in satisfactory condition, and all nuts and bolts are in place and correctly cross-tightened. The boatmaster has to ensure surfaces are properly prepared before applying any protective coatings or treatments to the ballast tanks. This includes cleaning, removing rust and scale. Vessel management should arrange for the application of appropriate protective coatings to prevent corrosion. These coatings should have corrosion resistant and be able to withstand the harsh marine environment. The boatmaster and the crew should be regularly monitoring the quality of the water inside the ballast tanks to identify any potential sources of contamination. This includes testing for pollutants, chemicals, and biological organisms that could lead to cross-contamination or damage to the ballast tanks. Also being aware of any unusual odor from the ballast tank venting system or sounding pipe. General corrosion appears on internal surfaces of the tanks left uncoated. The corroded scale frequently breaks off, revealing the bare metal, susceptible to corrosive attack. In tanks that have been coated, corrosion starts affecting the moment the coating starts breaking down. Determining thickness reduction in the steel plates is difficult unless excessive shrinking has occurred. Careful examination should be carried out in areas such as in the vicinity of sounding pipes and striker plates, openings for the air vents and tank gauging, internal piping including fittings, joints, and clamps near the operational valves in the tanks. The boatmaster checks the underside of the tank openings, bulkheads in general, joints associated with girders, web frames, etc. Pitting corrosion is often observed in the bottom plating of ballast tanks, especially near the bell mouth, or next to suction wells associated with the submerged pumps fitted within the tanks. Pitting corrosion begins mainly with the local breakdown of the coatings, exposing the bare metal, and thereby getting accentuated by oxidation and galvanic reactions in the area. Blister formation is a common sight in areas where the surface preparation is inadequate before application of paint coats or, for some reason, the coating failed to adhere to the surface. The boatmaster must look out for these bumps on the tank surfaces that may act as an alibi to the mounting decay underneath. The SALAS Convention contains provisions on corrosion prevention in seawater ballast tanks. Coal tar or surface-tolerant epoxy systems are typically used for ballast tank coatings. It's important to note that these tanks include baffles, so additional stripe coatings with high build, edge retentive properties are recommended. Prior to surface preparation, it is essential to ensure that any mud and/or sediments are removed. Mechanical equipment can be used to remove hard rust, followed by high-pressure water jetting. Stripe coat all sharp edges, corners, and weld areas by brush or roller. Stripe coating can be undertaken before or after the first coat. The primer coat is applied to the minimum dry film thickness. When the primer coat is touch dry, the top coat is applied. In contrast with ballast water tanks, the much smaller freshwater tanks are also essential for any ship, but have no anti-corrosion standard for the coating used. Coatings in these spaces must protect steel and not impart off-tastes to potable water. Typically, 2- or 3-coat epoxy polyamide or epoxy polyamine systems meet national standards. While cleaning the freshwater tanks, it is advisable to use high-pressure spray of fresh water. The spray machine is electrically operated on some ships. Care should be taken for proper insulation of them during use, and any risks of electrical shock should be eliminated.